This is right triangle trig. Trig is short for trigonometry. Trig, O, nom, O, tree. Oh, goodness gracious. It tree. Sorry, not E. It tree. Ooh, I almost spelled that wrong. Trigonometry. I was spelling it phonetically, and then I was phonetically saying it wrong, so I was spelling it wrong. Trigonometry. Trig, O, nom, et tree. There we go. Which is triangles. We're just studying triangles, angles, lengths, things like that, trigonometry. The reason I like it is because it's a good mesh of algebra and geometry together. And I think it's cool because as soon as you think that you have found all the relationships that they have, you can discover more layers of relationships, and it will blow your mind repeatedly. So the more you learn about it, the more it blows your mind, which is what I like about it. So we have in here, we have this angle, and it could be different angles. So we're talking about right triangles. That's why we call it right triangle trigonometry. So here's the right angle right here, and then you pick one of the other angles. It doesn't matter which one, so I picked this one. This letter right here, it's just an O, the letter O, with a horizontal line drawn through it, okay? This is the Greek letter, and it's the Greek letter theta. So you draw it like this, and it is the Greek letter theta, T-H-E-T-A. That's how you pronounce it, theta. And it is just like we use x typically as a variable in math, theta is the typical variable that people use when they do not have an angle. So when you have an angle that you're solving for, typically you call that angle theta. Okay? Another typical variable that we use for an angle is beta, and it's another Greek letter, and it's like a capital B, but it has a really long tail. So beta. B-E-T-A, beta. So it's a capital B, it just has a long tail. Does that make sense? And Jack, I'm going to have you put your laptop at 45 degrees, just because there's not a whole lot you can type with this right now. Okay. Yeah, no, I got you. It's just, it'd be hard to type them. Okay. So theta, beta, those are pretty common Greek letters to use for missing angles. Does that make sense? We good so far? Yes, Ms. Rice? Marvelous. Okay. So when we talk about these different angles, we talk about the sides of a triangle in relationship to those angles. So you guys already know the hypotenuse of a triangle. We've heard of that before, yes? Okay. So if this is the angle, then we would say that this side is opposite of that angle, and we mean opposite as in it's across from that angle. It's opposite, like if you think about someone who's opposite of you from the table, they're across from you on the table. Okay. The other side is called the adjacent side. Adjacent means next to. Okay, so opposite means across from, adjacent means next to. Does that make sense? Opposite, adjacent. Okay, so when we do this, we say that there are three different trig functions. Function, like we've learned about functions, as in there's x squared is a quadratic function, x to the third is a cubic function, the square root of x is the square root function, radical function. So we've learned about different functions. There are three trig functions that we're going to talk about just in Math 2, and then when you guys get to Math 3, they'll talk about three more. Okay, so the three trig functions we're going to talk about are sine. I'm going to write how they're spelled so you can see it. So it's sine, S-I-N-E. That's why it's not pronounced sin, is because that's actually an abbreviation for the word sine. It has an E on the end. This is cos, but it's a shorthand for cosine. And then tan is a shorthand for tangent. So sine, cosine, and tangent. Have you guys heard of those before? Yeah. Heard those words? Okay. So if you look at your calculator, there are buttons for those three words. Sine, cosine, and tangent. Sine, cosine, and tangent. And a lot of people say sine, cos, and tan. Sine, cos, and tan. If you ever call this sin, people will laugh at you. So we say sine. Okay? Make sense? We good? Okay. So each of these is a ratio. What's a ratio? A fraction. It's a ratio, and the ratio is comparing two of the sides of the triangle. Okay? So sine compares the opposite over the hypotenuse. It compares the opposite over the hypotenuse. So this ratio is always going to be less than 1 because the hypotenuse is the longest side. So this ratio is always going to be less than 1. Okay? The cosine is the adjacent over the hypotenuse. So that ratio is going to be less than 1. It's the adjacent over the hypotenuse. So since the hypotenuse is the longest side, that's always going to be less than 1. And the tangent is the opposite over the adjacent. And so that ratio, it could be less than 1, it could be greater than 1, it could be anything, because opposite over adjacent, those are just the two legs of the triangle. Two legs don't have a set relationship to each other. They could be less than 1, they could be greater than 1. We don't know which one's longer. Okay? So because of this, people write that sine is opposite over hypotenuse. They write it like this, and they call it SO. S-O-H. So. This is C-A-H, that's CA. So CA. And this is T-O-A, which is TOA. So people write this acronym. We're going to write this at the top of our notes. You might have heard it before. People write Sohcahtoa. This is not a word in another language. If people tell you it's Native American, that's a lie. It's not. This is gibberish. It's just what we use as an acronym to remember what the ratios are. Sohcahtoa. Have you guys heard that before? Sohcahtoa? Maybe? It sounds like a word in a foreign language. The math teacher that dressed up as a Native American and like pranced around, and that was very culturally insensitive and inappropriate. Yeah, so we don't do that. It's not any other language. It truly is not. It's just an acronym that math people have been using for a long time to help them remember when they first learn this, what the different ratios are. Okay, so Sohcahtoa, that's how we remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, any questions so far? How do your brains feel? Pretty good? Okay. All right, so Sohcahtoa is this first blank, Sohcahtoa. Only applies to right triangles. It doesn't apply to other triangles. So you have to have a right angle for this to work. The opposite and adjacent sides are relative to the reference angle. So you have to know which angle you're talking about. Are you talking about this angle or are you talking about that angle? Because if you switch the angle that you're talking about, then the opposite side is going to switch. The adjacent side is going to switch because the sides are labeled. The hypotenuse is always the hypotenuse, but the opposite side and the adjacent side are labeled based on the angle that you're talking about. So they will switch labels depending on the angle, okay? I already showed you, but there are sine, cos, and tan buttons on the calculator. Your calculator has two modes for angles. So in this class, we're only going to deal with degrees, but in Math 3, you're actually going to learn about radians, okay? So degrees, which is what we're going to use in Math 2, and radians, which is what you're going to use later in Math 3. Okay? Now, the default of your calculator, if you hit second plus 712 to reset your calculator, the default mode is radians. So if you reset your calculator is going to go back into the wrong mode. Okay? So the way that you switch the mode in your calculator, we're going to have everybody do this. There's a mode button. So go ahead and hit the mode button. You can see that your calculator says radians, it says degrees. and it is currently dark on radians. That's because my calculator is in radians. Your calculator is probably in radians as well. So what you're going to do to switch it, go down so that it is blinking on radians. You're going to go over to degrees so that it blinks degrees. You're going to press enter so that it is now dark on degrees. Everyone got it? So now my calculator's in degrees. That's what I want. So every time you clear your calculator, reset your calculator, do anything like that, it goes back to radians, okay? Because regular mathematicians, math people, once they get past basic math classes, they only work in radians. So once we get past Math 2 is pretty much the last class you would do a lot of degree work. After that, you start working in radians. Math 3 and above, we do radians, okay? So, and then if we want to get out of this, we can do second quit. And then our calculator is just in degrees, okay? But as soon as I do second plus 712 and clear my calculator memory, now if I hit the mode button, I'm back in degrees, or in radians again, because that's the default. Does that make sense? Okay. All right, so here's example 1. You can see that I labeled both angles. So what I'm going to do is I'm going to take 2 different colors. You guys have 2 different colors at your table? Okay, we're going to be holiday-esque here. I'm going to use brown for turkey. What other color should I use?
Orange and red.
What's the orange for pumpkin? I got it. Okay. Brown for, is it orange for pumpkin or orange for sweet potato?
No, orange for pumpkin pie.
Okay, but is it so are we pumpkin pie or sweet potato pie?
Pumpkin pie. This time,
should we take this to the parking lot or? All right, so the first ratios that we are doing are for theta. So I'm going to start by putting a little arc with theta. This is my first color. And so in my first color, I'm going to do all my labels in terms of theta, okay? So the hypotenuse is always the same. So I just can label the hypotenuse and know it's going to be just fine. So if this is the theta, then this is opposite. And then that means that this one right here is adjacent. See how that works? Opposite and adjacent. Okay. So let's think about this. We've got Sohcahtoa. So what does so mean? SOH. Opposite over hypotenuse. Okay, so what should I write for sine? 3 over 5. Okay, 3 over 5. Okay, and then cosine, so ca, what should I write for ca? Adjacent hypotenuse, which is? Wait, is it 5 over 4 or 4 over 5? 4 over 5. So it's adjacent over hypotenuse. Okay, and then TOA. Opposite over adjacent. So what did you say, Avery? 3 over 4. Okay, so we're done with that one. Now we're going to switch colors. We're doing pumpkin pie / sweet potato pie, whatever your preference is. Now, this is beta this time, and so the hypotenuse is still the hypotenuse, because the longest side is just the longest side. But now, if I look at what is across from beta, the names have switched. So now the one that is across is the 4. See how the names have switched? And now the one that is right next to it is this one right here. You guys see that? Okay. So if we do sine of beta, that's opposite over hypotenuse, and so my ratio is going to be different this time. What's my ratio this time? 4 over 5. Okay, what is adjacent over hypotenuse? 3 over 5. And then what's my TOA? 4 over 3. So see how both times, since these are opposite over hypotenuse and adjacent over hypotenuse, both of these fractions are less than 1, less than 1. You guys see that? Less than 1, less than 1. But these ones could be less than 1, could be more than 1 because they don't have the hypotenuse. So it kind of depends on what the legs are. Okay, how do you guys feel about that? Pretty good? Okay. Now, example 2, they gave us a triangle, but one of the sides is missing, so we're not going to do any work until we can do something to find the missing side. What do we know about finding a missing side length in a right triangle? Yeah, Pythagorean Theorem. Okay, so let's go ahead and do that. I'm going to label this as an x. So what should I write? Wait, is it 4 squared plus 7 squared? 4 squared plus x squared equals 7 squared, and that's because 7 is the hypotenuse. Okay, so we got 16 plus x squared equals 49. Okay. What does x equal? Okay. And we're just going to use the positive version. Is that a square root you can simplify? No? Okay. So this is just square root 33. Okay. All right, you guys want to use the same colors or shall we switch? Switch, make it more exciting. You got same? We're going to keep it same? Okay. Consistency. Okay. So we got turkey again. Okay, hypotenuse. Opposite. Okay. Adjacent. Okay. So what should I write for sine of theta? Four over 7. Okay. What should I write for cosine of theta? Root 33 over 7. Okay, and then what should I write for tan of theta? Are you allowed to write 4 over root 33? Okay, so I'm going to write an arrow down here. So we had 4 over root 33, and then we went, no, we can't have that. So how do we fix it? Multiply by what? And then what does that give us? Sorry, my fan is making noise. Okay, so what does it give you? Okay. Okay. All right, so that wasn't so bad. Okay, so let's do the other version. We got beta. Hypotenuse stays the hypotenuse. Hey, thank you, sir. Okay, so we've got this is the opposite side, and this is the adjacent side. All right, so what is sine of beta? Okay, root 33 over 7. Okay, what's cos of beta? 4 over 7. Okay, and then what's tan of beta? Okay, root 33 over 4. Okay, sound good? Okay, so I'm going to let us practice this for a little while before we do the next thing. The next thing we're going to do, I'll show you, just so you kind of know what's coming up, is we're going to have some information in a triangle like this, and we're going to solve for a missing side. Okay, so that's what's coming up. But before we do that, we're just going to take some information like this, and we're going to write down the different trig ratios. Sound good? Yes? Okay. So, I did not... No. So, the instructions for these types of examples are going to say, find the measure of the side, the missing side, or the side indicated. And then round your answer to the nearest thousandth. So you can see it's a right triangle, but it's not that they gave you two sides, and you're finding the third one where you could use the Pythagorean Theorem. It's where you have two missing sides. So if you have two missing sides and you want to find one of them, and instead of giving you two sides and one is missing, they gave you one side and one angle, that means you can use a trig ratio to solve. So what we're going to do is we're going to start by saying, okay, this is the angle that they're talking about, and we're going to label the two sides that they gave us. We're going to write the names of the two sides that they gave us in relation to that angle. So what, in relation to that angle, what is the x called? Opposite. So this is right across from the angle. This is the opposite side.
I know. That's what it sounds like someone's having a fire.
And then what is the 5 called in relationship to the angle? Adjacent. And which trig ratio uses opposite and adjacent? Tan, TOA. TOA uses opposite and adjacent. So what we're going to do is we're going to write tan 55.8, tan of the angle, equals opposite over adjacent. Tan of the angle equals opposite over adjacent. Are we good so far? Okay. So we know that we can do this when we have a right triangle. We have information listed, but it's not enough information to use the Pythagorean theorem. Okay? All right. Now, if I wanted to get the x alone, because I'm solving for x, and my goal anytime I'm solving for x is to get the x alone. If I want to get the x alone, what should I do? Multiply by 5, because right now it says divide by 5. So I'm going to multiply by 5. So I have 5 times tan 55.8 equals x. So there's a tan button in your calculator. So we're going to do 5 times tan 55.8. Now you're going to hit the mode button and just make sure that you're still in degrees. If you've cleared your calculator, if you've done anything, then remember it switches it to radians. So I'm just going to make sure I'm in degrees because triangles are in degrees. And then I'm going to hit 5 and then hit that tan button. Tan. Your calculator doesn't really care if you do or not. 55.8, you can close it or not close it. If you don't close it, your calculator will just assume that you meant to close it. Yep, there you go. And it said to round your answer to the nearest thousandth, which is 3 decimal places, so that is what we're going to do. So we got 7.357, and we're done. So x is approximately 7.357. Miss Rice, do I have to put the squiggly equal sign? No, you do not. You can put a regular equal sign if you want. You're good to go. You have to do tan because those are the two sides they gave you, was opposite and adjacent. We couldn't do the other ones because we didn't have information for those. So we do whichever trig function we have information for. Yeah. All right, let's look at number 4. So we have a 51-degree angle. Let's label the sides that we have. So the x is called what? What side is that called? Adjacent. Okay, this is called the adjacent side. And the 10.3 is called what? Hypotenuse.
Yeah, can we slow it down a little bit?
Oh yeah, notebook paper people.
Yeah.
So sorry. I'm sorry, notebook paper people. My sniffer's not as strong as your guys's is. Between the mask and my bad sniffer, I can't really smell anything. Yeah.
We both were like. Probably burning leaves. Well, why would you burn leaves right raining? I guess that's the safest time to do it. Maybe this is on fire. That wouldn't be very beneficial.
Oh my god.
What happens if the sun
I think there are, then other fire alarms would go off. There's not just only one.
That's like every single fire alarm.
Sophie's saying girly pop. Yeah, you said girly pop a lot. Girly pop. Go with Anna Thorne.
All right, notebook paper people, are you good?
Yeah.
Okay, so we labeled the two sides that we had. That tells us the only trig ratio we're allowed to use. So we got adjacent, we got hypotenuse, that's cosine, so what should I be writing? No. How do you pronounce it? Cos. I'm trying to make sure that future people do not make fun of you. Cos 51 equals what? X over 10.3. Okay. You're good. Okay. And then if we want to solve for x, what do we do?
He's moving at his own pace.
Okay, so we got 10.3 cos 51. Okay, here's a question, Miss Rice. Do people ever write cos 51 times 10.3? People typically don't write that because it would be confusing. You wouldn't know what needed to go in the parentheses on your calculator. So it is more common for people to put the 10.3 in front. Does that make sense? Okay. So it is not mathematically wrong to do it, but it would be confusing. That's why people do not do it. Okay, so this is what we should have on our calculators. Is this what you guys got? Okay, so we are writing 6.482. Okay. All right, go ahead and write down example 5. Now, example 5 gets a little more difficult, and I don't mean a lot, I just mean a little bit. So go ahead and write example 5 down. This is as bad as it gets. Okay, so this example is a little bit more difficult. It's as bad as it gets. I'm not saying it's terrible, but I am saying this is as bad as it gets. Okay, we're going to do 2 of them that are like this. Yeah.
Oh, like
All right, notebook paper people, here you go. But we don't say sin, remember? How do we pronounce it? Sine. I'm making sure that nobody makes fun of you in the future because it's a different word.
I can't wait to use sin and slip and slide on the EOG this year.
Oh, I just cringed so many times. That was very painful to hear.
Wait, are we gonna have like a couple weeks of review before the EOC?
There's no EOC for this class.
Teacher made.
It's a lot of great questions I don't have answers for. All right.
Much better than the
Wait, do we have a review?
Huh?
Do we have a review?
Let me talk to Miss Lopez and get back to you.
I did so bad on the
I am following Miss Lopez for everything. This class is not my baby. This class is Miss Lopez's baby. Math 3 is my baby. Yeah.
Why wouldn't math
Huh?
I thought we're supposed to be faster.
Honors isn't necessarily faster or slower, it does more. Yeah. All right. So the 8 side is called what? Opposite. What is the x side called? Hypotenuse. Yeah. All right. So what should I write? Sine 40 equals 8 over x. So this is what I was saying. This is as bad as it gets. These are the more difficult problems because the x is on the bottom of the fraction. So we can't just be like, oh, let's multiply the 8 over because it doesn't work like that. We're going to have to multiply the x over. It's going to help us get rid of the fraction, but it does not help us to isolate the x because the x is just as unisolated as it was a moment ago, but at least it's not a fraction. Not sin. Sine, thank you. All right, so we're going to divide by sine 40. Divide by sine 40. So x equals 8 over sine 40. So you can type this into your calculator using that fraction option where you do the alpha y equals. So you can type it in like this. Or you can just do 8 divided by sine 40. It's going to give you the same answer. So you can type it in like this. Or you can do 8 divided by sine 40. Same answer. Yep. So that's as bad as the problems get. It's not that bad. Nope. You just got to be careful and make sure that you notice that the x was on the bottom, not the top. So 12.446. All right, so let's do another one of those. Example 6 is the same way. So when we label the sides, what are they called? Opposite. Which one's the opposite? 11. Okay, so that's 30 degrees. This is called opposite. This one's called adjacent. Now, we already know what the x is. We don't even have to do the math. What's the x?
Wait, what? Oh, it's a 30.
It's a 30, 60, 90, so it's going to be 11 root 3. So now let's go ahead and use the trig to confirm that, okay? So it's an 11, it's a 30, 60, 90 triangle, so we know it's 11 root 3, but let's go ahead and use trig anyway. So this is opposite and adjacent, so what trig ratio is it? Tan, so we're going to say tan 30 equals 11 over x. 11 over x. So opposite over adjacent. And then what do we do? Times x.
Oh, my calculator died. I know because this mean it's dead. If I try to, it just turns off, and then if I try to turn it on, it kind of. Oh, it's not. It kind of just works.
All right. So that is exactly the number we expected it to be. So that's a good sign. We learned some math, and it mathed for us. Okay. So the other assignment that you're doing today was online last night, so you could have printed it. So the work for this does need to be done. You can do it on the assignment itself, or you can do it on a separate sheet of paper. It's up to you. Wait, what am I joking about? Yeah. Oh, if you No. What you could do for those of you who are notebook paper people is you could take like a screenshot on your cell phone and then do the markup thing and just like scribble through the maze. You know what I'm talking about? Like scribble. Yeah. Do none of you mark up your pictures? Anybody draw on their pictures? Yeah. We're going to do that tomorrow. The last page of the notes is for tomorrow, okay? If you are a notebook paper person, I'm just thinking that the maze might be hard to mentally keep track of. You do not have to draw the maze. I was just thinking, do you hear this fan sounding like a lawnmower up here?
Okay, but I love it. It's so calming. Like, I love the sound of it.
This is very annoying. The last page of the notes is for tomorrow. So guys, save this page for tomorrow. We're gonna do this tomorrow. No, for the maze, I was thinking that what you could do is take a screenshot of the Canvas one, and then on your phone, if you needed to, you could like scribble through it with the markup on your photo app on your phone if you needed something to like help you figure out what problem to do next. Since it's a maze, you do not have to draw it on notebook paper. I was just thinking you could do that if you get confused. Say it again. Doing what? You have to finish the punchline and then do this maze.
So we don't do 2 and 3 that we're doing.
2 and 3 what?
4 and 5.
So 1 and 2, we did 1 and 2. 3, 4, 5, 6.
Okay. Nice.
Okay.